So now let us see some applications of circular motion. Now you can consider, a car taking a circular turn, right? So if the car is taking a circular turn, that means it is moving along the circumference of a circle, or it is executing an arc, correct, of certain radius. Okay, so in that case, see, since it is performing circular motion, there has to be some centripetal force, correct, and it is a necessary force. So in absence of that, the car won't be able to take that turn along the circle. Now something has to provide this centripetal force, and that something in this case is the friction between the road and the tires, right? So I have this circular road here, and my car is here, and the wheels, okay, these wheels are experiencing some friction. So in absence of friction, the car would skid. Okay, so that means the friction has to act like this, in this direction, force of friction. Now suppose mass of car is m, then weight acts vertically downwards, mg, and the normal force here would have to be equal to mg, correct? Suppose radius of this curved road, if that is r, okay, and velocity of car is v, correct? Then the centripetal force acting on the car would be mv square upon r. Now that mv square upon r, that has to be equal to the force of friction. Now what is force of friction? Force of friction, this F is equal to mu times N, where mu is coefficient of friction between the tires and the road. Okay, and then what is this normal reaction? Normal reaction is nothing but its weight, correct? The total downward force is mg, so total upward reaction would be equal to mg. So it would be mu times mg, correct? So centripetal force has to be equal to the force of friction, so that means it would be mu times mg. So I cancel this m here and m here, so v square is equal to mu times rg, or v is equal to square root of mu into rg. So what does it mean? It means that the maximum velocity with which the car can safely take this turn, right, without slipping, that is square root of mu rg, right? But then you would think, if friction is taking care of this centripetal force, that means there is going to be some wear and tear of the tires, correct? The tires will wear out. So there has to be something that we need to do on this. And what do we do for that? For that, we do something which is called banking of roads. So when a road is curved, okay, then it is banked. So what is banking? Banking is raising the outer edge of the road over the inner edge. So it's like, inner edge is over here, and this is the horizontal. Then my outer edge would be like this. So the road would be, it would be tilted like that, right? So this angle theta here, it is called angle of banking. Okay, so now let us see how this banking really works. So now we are going to have this curved banked road. This is my horizontal level, and this is the level of the road. My car is here with mass m. This angle of banking is theta. My weight acts vertically downwards, that is mg. Normal reaction is here N. Now let us see what happens here. Now friction here is going to act in this direction. This is my F, correct? So let us resolve this N into vertical and horizontal components here. Also, I am resolving this friction in vertical and horizontal components. So this is my F cos theta, this is F sin theta, this is N cos theta, and this is N sin theta, right? Velocity of the car is V, okay? Angle of banking is theta. Now here, force of friction. What is the force of friction? Force of friction would be equal to mu times N. Okay, so let us consider equilibrium. So total force in the vertical direction and total force in the horizontal direction. So now here N cos theta, okay, N cos theta is in upward direction, mg is downward, and F sin theta is downward. So what I can say here is N cos theta, correct, it is equal to mg plus F sin theta, correct. And what about this? F cos theta plus N sin theta, and that will have to be equal to the centripetal force. So mv square upon r is equal to my F cos theta plus N sin theta. Correct. Now, what is the force of friction? Force of friction, it is mu times normal reaction. I am going to write it down here. F is equal to mu times N. Correct. So now equation 1 and equation 2. This 1 I am going to write here as mg is equal to N cos theta minus mu N sin theta, and mv square upon r is equal to N sin theta plus mu N cos theta. I'm going to call this 1 and 2. They are the same equations. I have just reproduced them here. What I'm going to do is I'm going to divide this second equation by the first equation. So 2 upon 1, that gives me, now obviously on the left hand side my m is going to get cancelled, correct? So my v square upon rg is equal to, now when you divide this, divide 2 by 1, see you see here n here, n here, 1 n here and 1 n here, correct? So what do you get here? You can cancel this n, so what you are left with is sin theta plus mu cos theta upon cos theta minus mu sin theta, right? Now let us do one thing here. Let us divide numerator and denominator by cos theta. So I divide sin theta by cos theta, that gives me tan theta plus mu cos theta upon cos theta, that gives me only mu cos theta upon cos theta is 1 minus mu into tan theta, correct? So then I'm going to write down the next part here. Therefore my v square is equal to rg into mu plus tan theta upon 1 minus mu tan theta, correct? If you remember, for a car traveling on a level horizontal road, my v square was equal to mu times rg, and now I am getting v square is equal to mu plus tan theta upon 1 minus mu tan theta into rg, correct? So now see, if you see here, mu is replaced by mu plus tan theta upon 1 minus mu tan theta, correct? So mu is added with something, and the sum, it is divided by 1 minus mu tan theta, correct? So obviously if you see, the denominator is less than 1 and numerator is greater than mu, correct? So obviously my velocity over here is greater than the velocity which I would get over here, correct? See, because whether the road is see, even though the road is banked, the coefficient of friction is going to be there, correct? And in addition to that, I am getting some help from this tan theta, isn't it? So suppose for this banked road, if the coefficient of friction is 0, if mu is equal to 0, then what happens? Then this is 0 plus tan theta upon 1 minus 0. So would it not be v square is equal to rg into tan theta, correct? So when the road is banked, even when there is no friction, you will still have some safe velocity of while taking turn, correct? But when you have some coefficient of friction and banking, then your speed with which you can safely drive along that curved banked road is greater, correct? So that is the beauty of this banking of roads, correct? We will be applying this in some numericals, right, to come, right? Thank you.